Hello everyone. Today let me explain y'all about the chloride content. Let me share the screen. Okay, what is our aim? We are going to determine the chloride content of any given water sample or wastewater sample by Mohr's method. Coming to the principle, in this experiment we are using the titrant silver nitrate and the indicator potassium chromate indicator. So now the chloride is determined by Mohr's method titration. So here when the chloride ions are determined by Mohr's method titration with the silver nitrate solution ions in which the silver chloride is precipitated at first. The end of the titration is indicated by formation of red silver chromate from excess silver nitrate and potassium chromate, which is used on an indicator in neutral to lightly alkaline solution. So here we are basically using silver nitrate as a titrant and the indicator is potassium chromate indicator. So how it reacts, what are the reactions, what happen in this experiment? The silver nitrate, AgNO3, reacts with chlorides which are present in the water sample to form silver chloride and nitrates. So at the beginning of the titration, we get a whitish color, cloudy color of the sample, which later turns from yellow to white cloudy to brick red. Then the silver nitrate, it reacts with potassium chromate indicator to form silver chromate and potassium nitrate. Now, one of the most important point of this experiment is we need to maintain a pH around 7 to 8. That is, we need to adjust the pH in between 7 and 8. Why? Because at high pH levels, the silver nitrate gets converted to silver oxide. So AgOH, that is silver hydroxide, is formed. At the same time, as we use potassium chromate indicator, the potassium chromate converts into O7, that is CrO4 minus 2 gets converted to O7 minus 2 at low pH values. Hence, the pH needs to be adjusted to 7 to 8. Coming to the theory, how chloride is present in any given water sample? What are the reasons? The chloride content can be added to water either naturally or artificially, that is due to anthropogenic activities or human activities. Chloride is present in all natural waters at greatly varying concentration depending on the geochemical conditions. At the same time, chloride is added to any natural water due to the leaching of the chloride containing rocks, chloride containing soils. So this is one of the natural attribution of chloride to any water body. The discharge of effluents from chemical industries, the ice cream plants, the effluents, the edible oil mill operations, all these, when they are added to any water body, when they are discharged without treating, they add up the chloride content in the existing water. In this way, the chloride content of the water body increases. Sewage disposal also is one of the main causes which adds chloride to the existing river water or any water source. What is the main reason is the leaching activity. We know the sewers which result in local contamination of both the surface water and the groundwater. The sewers carry their discharge from the various residences. They mainly carry the sewage. So sewage contains the human waste. It contains the human urine. It contains the human excreta. So a man discharges 8 to 10 gram per day of sodium chloride through both urine and human excreta. So in this way, when the sewage is disposed of directly into the water body, may be treated or may be untreated, or when it is disposed of in some area where the leaching of that sewage can happen and it can reach the water sources. So in this way, the chloride content increases in any existing water source. Next, one of the main reasons where chloride content increases is seawater intrusion in coastal areas. So what is this? In coastal areas, there are seas. The seawater may get added up through the flow, the underflow or the base flow, what we say. They come and intrude, enter the groundwater table or even the surface water bodies. So when such a thing happens, we say it is seawater intrusion. It has come and added up with the fresh water. So when this happens, the fresh water becomes salty because it is mixed up with the saline water by the intrusion process. So this seawater intrusion, when it happens, it increases the chloride content of any given water. Large amount of chloride reaches to the receiving water through leaching of domestic sewage as well as seawater intrusion. Hence, the chloride content has to be determined because it serves as a chemical pollution indicator. It indicates the chemical pollution of domestic sewage contamination when it is considered together with other parameters. When the chloride concentration increases more than 250 mg per liter. Moving on to the environmental significance, why chloride has to be tested and what is its significance, how it has an impact. So when any water which contains chloride in excess, it means it is associated with sodium. So we always say sodium chloride, NaCl. This results in exerting a salty taste, especially when its concentration is more than 250 mg per liter. Actually, there is no known evidence that chlorides constitute any human health hazard, which means lot of research is done, lot of studies are carried over where the people are using the water source which has high chloride content. But yet, there is no any health hazard reported. For this reason, the chlorides are generally limited up to 250 mg per liter in the supplies intended for public use, that is for various domestic purposes. The maximum permissible limit of chloride is 250 mg per liter. But yet, in many areas of the world, there are scarce water supplies. They don't have more sources. They are dependent on a few sources which are available. And that particular source may have large amount of chloride. Inevitably, they need to use the source because they don't have any other alternative. So when they use the water which has chloride content of more than 2000 mg per liter for various domestic purposes, fortunately, they have not developed any adverse effects, which means a high chloride content of 2000 mg per liter is consumed without any health hazard. Because once they start consuming such a water with high chloride content, the human body gets accustomed to that. It gets adapted to that particular water. And because there's no alternative, the sources with such high chloride content are used with no human health hazard. One of the most important point is when the chloride increases, it corrodes concrete. The corrosion is by extraction of calcium, which is present in the form of calcite. Magnesium chloride in water generates hydrochloride acid after heating, which is also highly corrosive and may create problems in the boilers. And one more most important point, when I said the chloride which is present up to a concentration of more than 250 mg per liter, it is usually associated with sodium and exerts salty taste. So once the salty taste appears, we can say sodium chloride is in excess. But there are also evidences that when the chloride content is present above 1000 mg per liter, yet it has not exerted any salty taste. So this mainly happens when the chlorides of calcium and magnesium are present. It may not exert any salty taste, but the chloride content is more. Moving on to the applications, the chloride determination in natural water is useful in the selection of water supplies for human use, as the permissible limit is limited to 250 mg per liter. So for any domestic water supply, we need to determine its content and say whether it is suitable for domestic supply or not. Chloride determination is also used to decide the type of desalting apparatus to be used. So whenever excess chloride concentration is present in any water sample, we need to remove the excess concentration. For that purpose, the removal of chloride is done by reverse osmosis method, by solar distillation method, by this desalting apparatus. So which type of apparatus to be used is decided depending on the chloride concentration determination. The chloride determination is also used to control pumping of groundwater from the locations where intrusion of seawater is a problem. Because the people in coastal areas, to have fresh water, they may be using any surface source or any groundwater source. But because the seawater has intruded, there is an intrusion of seawater in such fresh waters, and this will have imparted the chloride content to these waters. So the determination becomes very, very important so that we can have a control on the pumping of that particular groundwater in these coastal regions. The chloride interference is also helpful in the determination of chemical oxygen demand, COD. So to carry out the oxygen demand, we need to determine this chloride content, otherwise it will interfere in the decomposition of organic and inorganic matters of COD demand. A correction should therefore be made on the basis of amount of chloride present. So these are the various applications of chloride determination. Now, moving on to the experimental procedure, what is the apparatus required in the laboratory? We need burette, pipette, conical flask, measuring jars, pH meter. Reagents used: chloride-free distilled water, potassium chromate indicator, K2CrO4, silver nitrate solution, AgNO3 of 0.0141 normality. So this particular test, where we determine chloride content, is done in two stages or two steps. In the first step, we determine the chloride content of given water sample, and in the second step, we carry out the blank test. So indicator blank correction is very, very important, where it is known as blank test. We take a distilled water which is chloride free and we determine the chloride content, the titrant used, and always that is subtracted by the titrant value of the first titration. So this indicator blank correction or the blank test, why do we do? First of all, to have better accuracy. So whenever we add the titrant is added in excess so that a human eye can witness the color change. So excess of titrant is added where the titrant reacts with the indicator and we come to know the color change, the end point. So here excess amount of titrant is used, which is known as indicator blank correction. Finally, the titration of the blank test is subtracted from the original titration of the given water sample. Now moving on to the procedure. First step, or first stage of titration, where the sample is given whose chloride content is to be determined. We measure 50 ml of the sample. We place it in a conical flask. The next most important step is to adjust its pH. We have to adjust the pH between 7 and 8. So it is slightly alkaline condition. Because at high pH values, silver nitrate gets converted to silver hydroxide, AgOH is formed at high pH level, and the potassium chromate indicator which is used, K2CrO4, the CrO4 chromate changes or gets converted to O7 at low pH value. Hence, the pH needs to be adjusted between 7 and 8, slightly alkaline condition or slightly alkaline solubility. Once the pH is adjusted, so in case the pH is acidic, you need to add base and adjust it to 7 and 8. In case the sample is basic or alkaline, you need to add acid and adjust the pH between 7 and 8. So once this is done, the pH is determined using a pH meter, where the pH meter needs to be calibrated and the pH of the given water sample is adjusted by adding acid or a base. Once this is done, the pH is adjusted between 7 and 8, we proceed with the titration process. So we add 2 to 3 drops of the indicator, that is potassium chromate indicator, which imparts a yellow color. So once the yellow color appears, we titrate the solution or the sample against silver nitrate titrant of 0.0141 normality. You note down the initial burette reading. You start titrating till the end point is reached, that is yellow to brick red. Once brick red appears, you stop the titration. You note down the volume of titrate used. So you note down the final burette reading. The difference between final burette reading and initial burette reading gives us the volume of titrant used. Note down the volume of silver nitrate added as capital A. So it is in ml. Moving on to the blank test. So for better accuracy, we are going to titrate with distilled water. You're going to measure 50 ml of distilled water. You're going to transfer it to a clean conical flask. Here, we are not adjusting the pH because distilled water has a neutral pH around 7. Directly, you add the indicator. You add 2 to 3 drops of potassium chromate indicator. Light yellow color appears. You're noting down the initial burette reading and you're going to titrate against silver nitrate of 0.0141 normality till the color changes from yellow to brick red. So our end point is yellow to brick red. Once brick red has appeared, you're going to stop the titration. Note down the final burette reading. Note down the volume of silver nitrate added, final burette reading minus initial burette reading. You're noting down as capital B. Next, you need to carry out the calculations where A minus B. A is the volume of titrant used when you tested for the given sample. B is for distilled water. Equivalent weight of chlorine into normality 0.0141 into 1000 divided by volume of sample. You can just see the figure here. So the figure is enclosed. You can see the burette stand, the clamp, the conical flask. So in the burette, we have added silver nitrate, that is the titrant AgNO3 of 0.0141 normality. The conical flask has the sample plus potassium chromate indicator K2CrO4. So here the sample in the first stage will be adjusted with a pH between 7 and 8, and then the indicator is added. It gets a yellow color. Initial burette reading is noted down. It is titrated against silver nitrate till brick red appears. The final burette reading is noted down. Final burette reading minus initial burette reading will give you the volume of titrant added as capital A. Note down as AML. Next, you take distilled water. You add potassium chromate indicator. You titrate till you get yellow to brick red. Same way, you are going to note down the volume of titrant added as B, BML. So the calculations will be A, that is the volume of titrant added for the given water sample, minus B, that is volume of titrant added for distilled water, into equivalent weight of chlorine, into normality, into 1000 divided by volume of sample. This gives us the chloride content is dash mg per liter. So you're going to note down your result. The chloride content in the given water sample is dash mg per liter. And you need to conclude by comparing it to the maximum permissible limit, which is 250 mg per liter. If it lies within the permissible limit, we say it is suitable for domestic water supply. And if it is more than 250 mg per liter, depending on the value, we need to suggest the removal of chloride apparatus. Next, moving on to the Viva questions. Let me come up with these questions. First, what is meant by indicator blank correction? So why do we do this blank test? What is the principle of chloride test? What is the permissible limit of chloride content? What are its applications? What are the ill health effect of chloride content? What process is to be used to remove excess chloride content? Chloride concentration more than 1000 mg per liter does not impart salty taste. Why? How chloride content increases in water? Why do we need to adjust the pH between 7 and 8? What is the effect of temperature on determination of chlorides? This temperature is very, very important because at room temperature, we need to carry out this titration. If the temperature is high, the increased temperature raises or leads to utilization of more amount of titrant, that is silver nitrate. Hence, we need to maintain a room temperature. Thank you.